What's up everyone? Real talk. Amazon Web Services Organizations, SCPs, and Control Tower is where a lot of strong candidates lose easy points. Not you, not today. By the end of this video, you'll know how Amazon Web Services Organizations, service control policies, and Control Tower work together to govern dozens of Amazon Web Services accounts from a single place. We'll also clear up the single biggest misconception about SCPs, the one where engineers treat them like IAM policies and get burned. This is the multi-account governance layer of Amazon Web Services. In Episode 8 we covered IAM inside a single account, users, groups, roles, and policies. Then in Episode 9, CodeGorillas wired up IAM Identity Center, so their consultants could sign on once and reach all 40 client accounts. Today we go one level higher, not permissions inside an account, governance of the accounts themselves. 5 terms to anchor everything today. An organizational unit, or OU, is a folder that groups Amazon Web Services accounts so policies can be attached once and inherited. A service control policy, or SCP, is the guardrail you attach to that folder to cap what principals are allowed to do. A landing zone is the pre-built multi-account environment that Control Tower stands up for you. The account factory is how Control Tower vends new accounts on demand, and Resource Access Manager, or RAM, is how one account shares a resource with many others without copying it. Here's CodeGorillas' actual situation. 40 client accounts, spun up one at a time over 2 years, each one a slight variation of the last. Some of those OWASP block public S3 buckets, others quietly allow them. Some accounts can launch GPU instances, others can't, and nobody on the team remembers why. Every new client onboarding becomes a fresh checklist, and every checklist is a fresh chance to misconfigure something. This is the multi-account governance problem, and it's exactly what the services in this video are designed to solve. The whole game today comes down to this one sentence: you set the policy once at the top, and every account underneath inherits it automatically. No more per-account checklists, no more drift between client number 3 and client number 37. One rule, written once, applied everywhere. Everything we cover from here on is a mechanism for making that idea real. 4 services tell this story, and they each play a distinct role. Amazon Web Services Organizations is the platform. It gives you the account tree, the OS, consolidated billing, and policy inheritance. Service control policies sit on that tree as guardrails, capping what's allowed but never granting anything new. Amazon Web Services Control Tower is the automation that wraps organizations in an opinionated package, landing zone, account vending, pre-built guardrails, and Resource Access Manager handles sharing, letting one account own a subnet or a transit gateway and lend it to others. Keep those 4 roles separate in your head and the rest of the video falls into place. Here's the shape every Amazon Web Services organization takes. At the very top sits one management account, sometimes called the payer account. It creates the organization, it gets the bill, and by default it's the account that attaches guardrails. For specific services, the management account can also delegate policy administration to a designated member account, but that's an opt-in for each service. Underneath sits the root, which is just the top-level container for your OS. From there you carve out organizational units, like production, sandbox, and security, and each OU holds member accounts. CodeGorillas' Client A and Client B accounts would slot into the production OU, dev work goes in sandbox, and a dedicated log archive lives under security. Policies attach at the root, at an OU, or at an individual account, and they flow downward. If the tree feels abstract, picture a corporate org chart. The management account is the CEO, pays everyone, sees everything, but ideally doesn't do day-to-day work. OS are departments. Individual Amazon Web Services accounts are the employees inside those departments, and policies follow the hierarchy. A rule set by the CEO applies to every employee, A rule set by a department head applies only to people in that department. That mental model carries you through everything else. Inheritance is what makes this whole structure powerful. Attach a policy at the root, and every account in the organization is bound by it. Attach it at an OU, and it covers every account in that OU and any OUS nested below. An account's effective permissions are the intersection of every policy from the root down to the account itself. If any level says no, the answer is no. The practical implication is this: group your accounts into OUS by the policies they need to share, not by which team owns them. The OU is a policy container first, and organizational convenience second. Now to the centerpiece, service control policies. An SCP is a policy you attach to the root, an OU, or an individual account inside your organization. Its job is to set the maximum permissions any principal in a member account can use. Now here's the part that trips people up. An SCP is a JSON document with effect, action, and resource. So it looks exactly like an IAM policy, but it behaves completely differently. That difference is everything. And it's the next few scenes. Hold this picture in your head. An SCP is the guardrail on a mountain road. It tells you where you can't go, off the cliff. It does not move your car forward. You still need an engine for that. And the engine is an IAM policy. Guardrails restrict, IAM grants. Confuse those two and every SCP question becomes a coin flip. Side by side, here's the difference. An SCP limits what principals can do. It sets the ceiling, never the floor. It attaches to the org root, an OU, or an account, and it binds even the root user of a member account. On its own, it grants absolutely nothing. An IAM policy is the opposite shape. It grants permissions, starting from a baseline of deny, as we covered in episode 8. It attaches to a user, group, or role, and it doesn't apply to the root user of its account. And even when an IAM policy says yes, the request is still subject to any SCP sitting above it in the org tree. Both have to allow it for the action to succeed. Here's the misconception you have to actively unlearn. Writing an SCP that says allow on S3 put object grants nothing to nobody. If the IAM policy on the user or role doesn't already allow that action, the user still can't do it. SCPs are filters that sit on top of IAM. They can subtract from what IAM allows, but they can never add. Engineers default to reading them like IAM policies because the JSON looks identical, and that's the wrong model. SCPs only filter. Straight from the Amazon Web Services Organizations user guide, in case you ever doubt yourself on this, SCPs do not grant permissions to the IAM users and IAM roles in your organization. An SCP defines a permission guardrail, or sets limits, on the actions that those users and roles can perform. Amazon Web Services is unusually direct in their own documentation here. That's how often this gets misunderstood in the wild. 3 caveats to lock in. First, SCPs bind the root user of member accounts. Remember from episode 8 that IAM policies cannot constrain the root user. SCPs are one of the only mechanisms that can, which is a huge part of why they exist. Second, SCPs do not apply to the management account. That's why best practice is to keep the management account billing only, with no real workloads in it. Anything you run there has no guardrails. Third, Amazon Web Services attaches a default policy called Full Amazon Web Services Access at the root. Remove it without putting an explicit allow in its place and you've just silently blocked every action in every account below, because SCP evaluation is deny by default. Amazon Web Services spells out the second caveat directly. SCPs don't affect users or roles in the management account. They affect only the member accounts in your organization. So if a question describes a workload running in the payer account that's somehow being blocked by an SCP, that's a wrong answer. The payer account is outside the guardrails entirely, which is exactly why nothing important should live there. Here's what a real SCP looks like in practice. The pattern is a deny on all actions and all resources, with a condition that fires whenever the requested region is not in an approved list. Here, US East 1 and US West 2. Attach this at the org root, and every account in the organization is now physically incapable of launching anything outside those two regions. Even a root user in a member account who tries to spin up an instance in another region gets access denied. Notice the SID, deny outside approved regions. That's the descriptive name that shows up in error messages so you can find which guardrail blocked you. Quick checkpoint. Organizations gives you the tree, management account at the top, OUS in the middle, member accounts at the leaves. SCPs are the guardrails you attach to that tree, and they only ever limit. Coming up next, we look at how the same tree gives you a single bill with pooled discounts, and then how Control Tower automates the entire setup so CodeGorillas doesn't have to build it by hand. Consolidated billing is the financial side of organizations, and it's a quiet superpower. You get one bill for the whole organization, paid by the management account. There's no additional charge to turn it on. It's just how organizations works by default. The interesting part is that usage from every account gets pooled when Amazon Web Services calculates tiered and volume discounts. Reserved instances and savings plans sharing works the same way, on by default, with one nuance. The discount only flows from one account to another when both the purchasing account and the receiving account have sharing turned on. So it's shared by default, but it's not unconditional. Think of it like a Costco membership for the whole family. 5 family members each buying £20 of coffee separately all pay retail. Pool them under one membership card buying £100, and you cross into wholesale pricing. Same purchases, lower per unit price. That's what consolidated billing does for Amazon Web Services usage. Your 40 CodeGorillas client accounts, billed together, qualify for tiers no single account would ever reach on its own. Here's the Amazon Web Services billing user guide stating the benefit directly. You can combine usage across all accounts to share volume pricing discounts, reserved instance discounts, and savings plans, and this can result in a lower charge than with individual standalone accounts. 3 things to remember from that quote: volume tiers pool across accounts, reserved instance discounts are shared, and savings plans are shared. Now to Control Tower. Control Tower is an opinionated, managed service built directly on top of Amazon Web Services organizations. When you turn it on, it stands up a multi-account landing zone for you, using Amazon Web Services' own best practices. You get a pre-built OU layout, a dedicated log archive account, a dedicated audit account, and IAM Identity Center already wired in. And it ships with a catalog of guardrails, preventive, detective, and proactive, that you can switch on with a click. Where organizations gives you the raw building blocks, Control Tower hands you a working environment. Here's the cleanest way to remember the relationship. Organizations is a vacant lot. You can build anything on it, but you have to pour the foundation, run the wiring, and install the plumbing yourself. Control Tower hands you a furnished starter home. Security cameras are CloudTrail. Smoke alarms are config, the locked doors are SCPs, and there's a key cutting machine in the garage. That's the Account Factory, which is up next. Account Factory is the feature that turns CodeGorillas' onboarding nightmare into a self-service request. Amazon Web Services literally refers to it as the account vending machine in their own docs. You press a button, drop in a few parameters, and out the bottom pops a fully configured Amazon Web Services account. It's already enrolled in the right OU, so it's already inheriting every guardrail you set there. It's already wired into the central log archive, and it's already accessible through IAM Identity Center with the right permission sets. What used to be a multi-hour checklist becomes a form submission. Control Tower's guardrails split into 2 camps you need to keep separate. Preventive guardrails block the action before it happens, like denying any launch outside approved regions, or denying anyone from disabling CloudTrail. Under the hood, These are implemented as SCPs enforced by Amazon Web Services organizations. Detective guardrails take a different approach. They allow the action, then flag it as a violation after the fact, like alerting when a public S3 bucket appears, or when an unencrypted EBS volume gets created. These are implemented as Amazon Web Services config rules. Managed rules run built-in checks, while custom rules can invoke Lambda for more specific logic. The mapping to remember: preventive is SCPs, and detective is Amazon Web Services config. If you remember nothing else about these two services, remember this: Organizations is the platform. Control Tower is the opinionated automation built on top. Control Tower cannot exist without organizations underneath it. When you turn on Control Tower, it creates an organization or uses an existing one. The decision rule for the exam is simple. Words like OU, SCP, and Consolidated billing point to organizations. Words like landing zone, account factory, and vending point to Control Tower. One nuance on cost: there's no additional charge to use Control Tower itself, but when you set it up, you start incurring costs for the underlying services it turns on. These include CloudTrail, config rule evaluations, and S3 storage for the log archive. Config rule evaluation is usually the biggest line item. CloudWatch and SNS, the simple notification service, also contributes smaller amounts. So Control Tower is free, but the house it builds for you isn't free to run. The last piece is Resource Access Manager, or RAM. RAM lets one account share specific resources with other accounts, without duplicating them. The classic examples are VPC subnets, transit gateways, license manager configurations, and Route 53 resolver rules. The usage pattern is hub and spoke. A central networking account owns the transit gateway. Every workload account attaches to it through RAM. One piece of infrastructure, many consumers, build centrally, and RAM itself is free. You only pay for the underlying resource being shared. Picture an apartment building in winter. Instead of every tenant going out and buying their own snowplow, the building owns one in a shared garage, and any tenant can grab it when they need it. That's RAM1 transit gateway, one set of subnets, one license configuration, sitting in a shared garage that any account in the organization can pull from. The alternative is a tangled mess of VPC peers and duplicate resources, which is exactly what RAM exists to avoid. Putting it all together for CodeGorillas, here's the migration path. Step 1. Enroll in Control Tower. That alone gives them a managed baseline with audit and log archive accounts they don't have today. Step 2. Redesign the OS around policy needs, not client team names. Step 3. Attach SCPs at each OU, deny public S3, restrict to approved regions, limit GPU instance families. Step 4. Route every new client through account factory, so guardrails apply on day 1 instead of relying on someone remembering a checklist. And Step 5. Share networking with RAM, stand up one transit gateway in a central networking account, and share it through Resource Access Manager, so every client account plugs into the same network instead of building its own. 5 steps, and the sprawl problem becomes a managed platform. Here's the cheat sheet. These keywords map to these services. Consolidated billing, OU, or SCP points to Amazon Web Services organizations. Landing zone, account factory, or vending points to Amazon Web Services Control Tower. Sharing a subnet or transit gateway across accounts points to Resource Access Manager, or RAM. A guardrail that blocks an action is preventive, implemented as an SCP, and a guardrail that detects a violation after it happens is detective, implemented as an Amazon Web Services config rule. 5 mappings, and a lot of scenario questions collapse to one of them. 5 things to walk away with. SCPs set the maximum permission ceiling. They limit, never grant, and they bind the root user of member accounts but not the management account. Amazon Web Services Organizations is the underlying account tree, with consolidated billing as a free bonus. Control Tower is the opinionated automation on top of organizations, with a landing zone, account factory, and pre-built guardrails. Preventive guardrails are SCPs, detective guardrails are config rules, keep that pairing straight, and RAM shares specific resources across accounts without duplicating them. Now let's see how well that landed with a quick 5-question quiz. Alright, time to put what you've learned to work. Question 1. A developer in a member account has an IAM policy that allows S3 put object. The OU containing that account has a custom SCP that replaced the default full Amazon Web Services access policy, but has no statement mentioning S3. The put object call fails. What is the most likely cause? Is it A, the IAM policy needs to be reattached after the SCP was added? B, the OU's custom SCP replaced full Amazon Web Services access without including S3, so all S3 actions are now denied by the guardrail. C, SCPs automatically deny S3 actions unless an explicit allow is added. Or D, the developer needs to assume a role in the management account. Pause here if you want more time. The right call here is B. SCP evaluation is deny by default if the default full Amazon Web Services access allow gets replaced at an OU, and the replacement doesn't list S3, no S3 action can pass through, even with a perfect IAM policy underneath. The lesson is that SCPs are filters layered on top of IAM, and both layers have to allow the action. Question 2. A consulting firm wants to provision new client Amazon Web Services accounts with a standardized OU placement, baseline guardrails, central log archive, and SSO access, all automatically. Which Amazon Web Services service is purpose-built for this? A. Amazon Web Services Organizations. B. Amazon Web Services IAM Identity Center. C. Amazon Web Services Control Tower. Or D. Amazon Web Services Resource Access Manager. Lock in your answer before I give it away. It has to be C, and here's why. The keywords, standardized account provisioning, baseline guardrails, log archive, SSO wiring, all point to Control Tower's account factory. Organizations alone gives you the tree but not the vending machine on top. Identity Center handles workforce sign-on, and RAM handles resource sharing, different jobs. Question 3. Which statement about service control policies is correct? A. An SCP that allows EC2 run instances grants the EC2 launch permission to all users in the affected accounts. B. SCPs apply to users and roles in the management account as well as member accounts. C. SCPs are evaluated independently of IAM policies, so either one alone can authorize an action. Or D. SCPs can limit what the root user of a member account is permitted to do. Run the decision rule from earlier before you answer. The answer is D. SCPs are one of the only Amazon Web Services mechanisms that can constrain the root user of a member account, which is a major reason they exist. A is wrong because SCPs never grant, they only limit. B is wrong because the management account is exempt from SCPs, and C is wrong because an action requires both the IAM policy and every applicable SCP to allow it. Question 4. A central networking account owns a transit gateway. The team needs dev, staging, and prod accounts in the same Amazon Web Services organization to attach their VPCs to it, without copying the resource. Which service should they use? A. Amazon Web Services Resource Access Manager, or RAM. B. Amazon Web Services Private Link. C. VPC peering. Or D. Amazon Web Services Direct Connect. Got your pick? Let's see. If you said A, well done. RAM is the service designed to share specific resources, transit gateways, VPC subnets, license manager configs, Route 53 resolver rules, across accounts in an organization without duplicating them. The sharing itself costs nothing extra. VPC peering creates point-to-point links, private link exposes individual services, and direct connect is a dedicated line from on-prem. None of them solve this sharing problem. Last one, and this one tests a concept from an earlier episode. A company has 40 active Amazon Web Services accounts and dozens of consultants who need access to different subsets of them. Each consultant signs in once with corporate credentials and is routed to permission sets in the appropriate accounts. Which Amazon Web Services service is providing this capability? A. Amazon Cognito User Pools. B. Amazon Web Services Directory Service Simple AD. C. Amazon Web Services IAM Identity Center. Or D. Amazon Web Services Resource Access Manager. Think about which service was built for Workforce Single Sign-On. The right call here is C. IAM Identity Center, which we covered back in episode 9. It's Amazon Web Services' centralized workforce single sign-on across multiple accounts in an organization, with permission sets assigned to groups. Cognito is for the end users of an application, not workforce access. Simple AD is a lightweight directory, not a sign-on service, and RAM shares resources, not identities. This is exactly the pattern CodeGorillas uses today, and Control Tower wires Identity Center in for you automatically when you turn it on. And that's everything you need on Amazon Web Services Organizations, SCPs, and Control Tower for the exam, and most of what you need for the job. Like, subscribe, and onwards.